1.3 is going to have two parts. Part 1 is going to be types of discontinuity. So we are going to have 3 types of discontinuity. I am going to show them right here. So just draw some simple graphs. And what is going to happen is it's really going to be based on fractions, or sometimes when you have restrictions. Like, for example, you cannot have 0 in a denominator. If you have 0 in a denominator, then you're going to have something that's called an asymptote, and I know you guys have heard that before. Asymptotes create blocks on a graph. So if you have an asymptote like this, you could very well just have a couple of branches here on either side of that asymptote. So remember, an asymptote is usually where x cannot equal 0, or x cannot equal some number. We'll call it a constant. Whatever that number is, it would possibly make the equation undefined. And remember, most importantly, these graphs are called, or these asymptotes are called infinite discontinuities. So that asymptote creates an infinite discontinuity at wherever this value is. It is always going to be a vertical line though, because it's always an x equals type of graph. So always a vertical line, always infinite discontinuity. Really easy to spot because they're asymptotes. The next thing that we have, you've kind of seen a little bit. It's from usually a piecewise function. And it is going to be considered a function. It's just going to have a jump. And that is going to be created by space from outputs. And this is going to be called a jump discontinuity. And real simple, usually I use red pens to show like asymptotes. I'm not even going to use a red pen in my graph here. What this is going to look like is going to be possibly, let's say you have a piece of a line. And that line's just going to stop somewhere on the negative side of the x-axis. But it picks up again above the origin, and then maybe it continues forever, like with part of a parabola. So if you notice, there's not a vertical asymptote where it creates branches, and it is filled in. If you see, it is open right here, but I purposely filled it in right above. It's just if I trace this graph, I'd have to jump to go to the next piece. That's why it's called a jump discontinuity. And then the next one that we have is a hole. So a hole is going to be, again, we can use a line as an example. Let's say I have a line with a negative slope. And I have a discontinuity where a line is, like we would hop over that. So this is caused when factors cancel. And when I say they cancel, I'm talking about a numerator and a denominator type situation. And these are usually called holes, and they are called removable. I could actually fill that in using a piecewise function. See how that's open, but I filled in that x value up there. Same thing, I could fill it in, but remember, a hole is a single point, and that is a removable discontinuity. And those are types of continuities. Now we're going to talk about how they happen.